Hello everyone, welcome to Illustraca. So today in this lesson we are going to see how to define the seismic mass for the seismic load calculation. So here most of you know how to define the seismic mass. It is a very simple process, but the pain point that many of my subscribers, many of my students have asked, that how to implement this particular clause that we have in IS1893. I have shown this many times, but still people have doubts, so I thought of making a lecture on this simple topic. So the clause, if you see in the table 10, that it is saying that we need to make some reductions in the live load when calculating the seismic mass, and that reduction should be as per the table 10 of IS1893 part 1 2016. So it says percentage of imposed load to be considered in calculation of seismic weight. So we will be considering a certain percentage of seismic load, live load, or you can say imposed load, for calculation of seismic weight. So what is the percentage given? So if you see here, up to and including 3 kilonewton per meter square, we will be considering 25% of the load only for seismic load calculation, and above 3 kilonewton per meter square, we will be considering 50% of the total imposed load. Okay, so total imposed load means those imposed loads which are more than 3 kilonewton per meter square. For those, we will be considering 50% of that, and those equal to or less than 3 kilonewton per meter square, we will be considering 25% of those loads. There is one more thing: for calculation of design seismic forces buildings, imposed load on roof need not to be considered. So the roof live loads we do not consider, or we need not to be considered in seismic mass calculation. So how will we differentiate with these three live load cases? Okay, that we have three cases: 25%, 50%, and no live load, no roof live load in the seismic mass. Then how we will create this differentiation? Okay, so let's jump into the software. And if you see here, if I go to the load pattern, generally these are the two basic load patterns defined. We used to see this dead and this live. Okay, and then we have this, I have defined this seismic load cases, you can see, for x direction and for y direction. Okay, so these load patterns will help us to calculate the seismic, you can say, horizontal acceleration coefficient. But along with this horizontal acceleration coefficient, what we need the seismic weight. So how we do that seismic weight? So if you see, if I go to define and seismic mass source, you can see, not seismic mass, it is mass source. There will be one mass source. If I just click on modify, here I can define the mass source for my seismic mass calculation. Okay, so now before that, how to differentiate these three, you can say, loads? Live load less than or equal to 3 kilonewton. So we have three cases. One is, live load less than or equal to 3 kilonewton per meter square, live load greater than 3 kilonewton per meter square, and roof live load, which need to be excluded from the seismic mass. Okay, exclude, and these two we need to include for this 25%, for this 50%. So we need to create these three conditions in the same mass, you can say, seismic mass. So how to do that? So basically what we do, we create three load cases for the live load. Okay, so you can name it in your own way. What we do, I define this as live 1. Okay, I define the live load greater than 3 kilonewton as live 2, and the live load which will be assigned to the roof, that we consider, I make it as live 3. You can directly write it as live less than or 3 kilonewton square, live greater than 3 kilonewton, and roof live. That also, these are just names, so your consideration you can represent in any way. Fine. So now what I will do, I will define the same in my load pattern. So let me just go to my define. I'll go to define. and I'll go to load patterns. Now you can see, as we have defined this dead load and live load, which is the by default, and we have defined this SDL, superimposed dead load and earthquake loads, the same is replicated in the my load cases. Okay, you can see dead load, SDL, live. Okay, and this live, if you just modify, you can see the load pattern is selected as the live load pattern. Fine, but we need now 3 live load you can say cases. So I'll just go to define load patterns. This live load I already have. I will change the name to live 1. So I'll just change the naming here of the load pattern as live 1. The type will be same. I'm just modifying it. Okay, or else what you can do, you can delete this totally and you can create new load case. Suppose live 1, it will be of live type, and I'm adding new load case. Then I need live 2, same live, and live 3, and add. Okay, the load type will be live, and as you know, self-weight multiplier will be 0 because the self-weight will be calculated only under this dead load case. Okay, so we have defined 3 live load patterns. So as we know that these live load patterns will be replicated to my live load cases. I'll just go to define load cases, and you can see at the bottom 3 load cases are defined. Okay, so now suppose for some reason, for any technical glitch, that these live load cases are not coming here. Okay, so if you just modify, you can see under this live 1, my load pattern is also live 1. Okay, under this live 2, my load pattern is also live 2. Okay, under this live 3 case, my load pattern is also live 3 case. Now for some reason, if your load cases are not created here, okay, or if you have modified the earlier one, what will happen? Here you will see the name is coming like this only. Suppose you have modified the earlier load pattern that we have as live, you will see in the load pattern you change the name as live 1, but here in the load case it is showing as live only. But if you modify, you can see the load pattern selected is live 1. Okay, so you just have to change the name here. This is just the namesake. So you can just have to change the name in the load case as live 1. Under this live 1, we have the load pattern selected as live 1. I'll click on OK. Now what if these load cases are not created? Okay, so what I will do, I will just delete this, and I'm saying that these load cases are not created in the load case. We have defined it in load pattern. I'll show you. These are there in the load pattern, live 1, 2, 3, but these are not there in my load case for some reason, suppose. Now what we will do? Many people have this question. So what I will do, I will add new load case. I will name the load case as live 1. Obviously the load case, live load, dead load, these are my linear static load. So you can see here for the dead load also it is linear static load, right? Now here what I need the load type, I need the load name, that is a load pattern name, and I need the scale factor. Okay, so I'll just add it here. Load pattern, load type is load pattern because we have defined the load in the load pattern. Which pattern it will be? It will be live 1 pattern. What will the scale factor? So obviously whatever value we assign under this load pattern, the same should be replicated in the load case also. So the scale factor will be 1 here. I'll click on OK. Okay, similarly I will maybe modify or I'll make a copy of this. I'll change the name to live 2. Live 2. Now I will change the load name. Here the pattern will be live 2, scale factor will be 1. I'll click on OK. Same, I will make a copy of this. I'll make live 3 here, and I'll change the load pattern as live 3. Okay, so even if these load cases are not created, then you can create and you can assign the load pattern inside this, except your response vector load case, because response vector definition is different. In case of linear static, as we have option to define those linear static loads using our load pattern option, so we can define the load pattern there and automatically it will be replicated in the load case. If the load cases are not created for some reason, you can create by manual method also, that I have shown you. Same for the dead load and same for the model. Suppose here in the load pattern it is dead. Now here in the load case you want to run it as self weight, or you want to run it as capital dead. So just the name that you are changing here. Suppose I make it as dead. It is just the name, you are not changing anything else, because under this load dead load under load case, what is the load pattern selected? This is the dead load pattern which is we have defined. So the name is just you are changing here, not the load value. Okay, so I have kept it same. Now I'll click on OK. So I have defined 3 load cases. Now intentionally what I will do, I'll go to story 1. I'll go to here and I will select all the slabs and I will assign some. Suppose these 3 slabs I will leave. These slabs I'll go top, story 3, these slabs, and I'll go to story 4, these slabs, and story 5. I think story 5 is the last story, right? So story 5 I will not select, this is my roof, right? So I'll select only up to story 4 from story 2, only these side slabs, and I will assign. Suppose I want to assign some load which is less than 3 kilonewton per meter square in these slabs, right? So what I will do, I will go here, assign, go to shell loads, uniform. Now as the load that we are applying, the extent of that live load is less than 3 kilonewton per meter square. So which load pattern will be selecting? So we'll be selecting the load pattern number 1, which is live 1. So I'll select live 1. Suppose I will assign 2 kilonewton per meter square and I'll click on apply. Now these mid slabs, okay, story 2, story 3 and story 4. Now these mid slabs, suppose we want to assign some load of 4 kilonewton per meter square, which is greater than my 3 kilonewton per meter square. So in that case, which load pattern we will be selecting? We will be selecting load pattern 2. So I'll change the load pattern as load pattern 2. I'll change the value as 4 kilonewton per meter square and I'll click on apply. Okay. Now what is the left? Now we are left with the roof load. So I'll go to the roof. I'll select all the slabs. Okay, and I will apply a roof load of suppose 3 kilonewton per meter square on the roof. I'll select the live load 3. So roof load is nothing but live load 3, and I'll select this 3 kilonewton. I'll click on apply. Okay, so here I have selected one story, so only this story will be assigned with this particular load. Below there will be no live load 3, right? So if I just go to 3D view, you can see I'll select live load 3 and it is only assigned at the roof. I'll select live load 2, I'll apply. You can see it is only assigned up to this floor and only in the middle slabs. I'll go to live load 1, apply, and these are only applied in the side slabs and a value is less than 3 kilonewton per meter square. So we have got 3 different live load cases for 3 different extent of loads and 3 different areas. Fine. Now what is our case? Our case is to define such mass source, or which is our, you can say, seismic mass. Seismic mass or seismic weight. So for seismic weight, what is the combination that we will be creating? We will be creating a combination of dead load of 100%, live 1, which is live load greater than or equal to or less than or equal to 3 kilonewton, it will be then 25%, and live 2, as it is greater than 3 kilonewton per meter square, it will be 50%, and live 3 will be excluded, it will not be added. So now we jump into the mass source definition. So I'll go to define. We go to mass source here. You can see we have an existing mass source. You can modify this or you can create another one. I'll click on this add new mass source. Here as we have mass source 1, so 2, so I'll click on this mass source 1, and you can see this that the self-weight element, self-weight additional mass, we do not want this. What we want to specify our own load patterns. So here I'll select the specified load patterns, and here you can see as the load pattern is dead load, so the multiplier will be 100%. That means 1. So whatever load it is, it will be multiplied by 1 and it will be added to the seismic mass. I'll click on add, and then I'll select this live one. So live one is nothing but the live load less than 3 kN per meter square. So I'll be taking 25% of it. So you can write 25 divided by 100 or 0.25 directly. You can write, actually, sorry, I think here it is not calculating. Let me see. Generally ETABS calculates, but here it is not doing. So let me just write it here, 0.25, and add, and the live load greater than 3 kN per meter square, it will be of 50%. So here I will add it here, 0.5 as the multiplier. So all the loads assigned under this live load 2 pattern, which are more than 3 kN per meter square, will be multiplied by 0.5 and we'll be getting the 50% of the load, right? So 4 kN we have assigned. If it is multiplied with this half, so obviously it will become I can say 2 kN per meter square, right? So it will be you can say added here in the seismic mass. So I'll click on add. Now this live 3, it will be excluded, as we have said, that because this live 3 is the roof live load and it should not be added in the seismic mass. So this is how we can add the, you can say, 2 live loads of 25% and 55% extent and the whole dead load. Now this include lateral mass. You have to, as we are calculating the, you can say, seismic force along the horizontal direction, so that mass, a percentage of mass will be acting as a force, because we know seismic force, it is nothing but a you can say inertial force. So the mass of the particular story, a percentage of that will be acting as the force along the lateral direction. So include lateral mass, and this lump lateral mass at story levels, we all know that we consider the buildings and all as a combination of many single degree of freedom structures or a multi degree of freedom structure, you can say. So what we consider that the mass of the whole story is lumped at the story level and the force is acting on the mass. Why it is lumped at the story level? Because we all know that the slab at the floor level, we are having higher concentration of stiffness, and hence at the floor level itself or the slab level itself, the seismic force is to be seismic force is acting, and it is acting at the center of mass, right? So that at the center of mass, we consider that the whole load of the story is being concentrated at the center of mass at the floor level. Okay, so this way this lump lateral mass at story levels need to be selected. And if you want to have the vertical acceleration also in your analysis, so in that case, while you can say defining the vertical acceleration load case, you have to include this vertical mass also. Okay, so then if you check this, then only the vertical mass will be added, and the AV value that you are calculating vertical acceleration, that will be multiplied with the vertical mass, and that will give you the vertical you can say vertical base shear, okay, or the vertical force that you are getting. So that you can check or you can uncheck also, doesn't matter for now, as we are doing only the horizontal you can say we have added only the horizontal acceleration here. So I'll just click on OK. So here now this mass source 1 you can say is there, and mass source 2 is there. Okay, so I'll just click on OK. I'll go to define, I'll go to load patterns, and I'll go to my seismic load pattern, and I'll modify this, modify lateral load. Fine, modify lateral load. So now we have defined this AH here. Now can you tell me which mass source will be used for the calculation of seismic mass here? which mass source will be used for the calculation of seismic mass. Though it is not visible here, let me go to the response spectrum load case or modal load case so that you can see it. In the static load case it is not visible. I'll go to my response spectrum load case, that is I have already designed. Here you can see the mass source that is selected here is my mass source 2. So using the mass source 2, the seismic mass will be calculated. But we have defined the mass source in our mass source 1. But here by default it is taking mass source 2. Why it is being done like this? Because let me clear this. Because if I go to define and mass source, you can see here one option is there, default mass source. So if there is multiple mass source defined, which mass source you want to use for the software to calculate the seismic mass, that you have to select here. So we have defined the mass in the mass source 1. So you have to change it to mass source 1. In case of only one single mass source, then it is not an issue. Automatically that will be selected, right? But suppose my mass source 2 I have made it by default. Okay, so you can see this mass source 2 you cannot delete as I made it as by default. So mass source 1 you can delete because it is not the default one. But whenever you are defining a different mass source, you have to select here which mass source you want to use for the seismic weight calculation. So now our mass source is mass source 1. I'll click on OK. Now if you go to define, let me show you in the response spectrum load case. Here you can see by default now it is changed to mass source 1. So that is the mass source that will be used for the seismic weight calculation of. Okay, same for the static also. Okay, for the static also the mass source will be used as the mass source 1. Fine. So I hope how to define the mass sources for the seismic load, static, dynamic, whatever it is, mass source will be always same, right? Just the mass of the building, seismic mass of the building. So I hope all of your doubt regarding the mass source definition is clear. Okay, so if you have any query regarding this, you can always write me in the comment box or in the chat. I will try to solve those as early as possible. Thank you and see you in the next lecture.